The p-chart is used to control the fraction of non-conforming units. It's based on the binomial distribution, so assume that you have a steady stream of production. And the p, the proportion of non-conforming units, should be small. And therefore, the subgroup size should be large enough so that you can have several non-conforming units in each subgroup. And therefore, you should have at least 50 units in one of your subgroup. And the procedure of constructing the p-chart with constant subgroup size is very much alike the procedure for the X-bar chart and R-chart. On the other hand, for the p-chart, we can have variable subgroup size. So that means you can have different number of units that you draw in different subgroups. Here is a table for the computer modem final test and the control limits. And as you can see, in different days, we inspect different number of units. So this is the p-chart with variable subgroup sizes. And for each day, you have this number of inspection, and then you record out of this n value, out of this total number of units that you inspected, how many of them are non-conforming units. And then you have to compute this p-value, which is the NP divided by n. So this is the individual fraction of non-conforming associated with each subgroup. So for the p-chart with constant subgroup size, we will compute a uniform upper control limit and lower control limit for all the subgroups. Now, for the p-chart with the variable subgroup size, you have to compute this UCL and LCL for each individual subgroup. So the formula we use for the p-bar is the same as the constant version. So the p-bar is the central line, the average fraction of non-conforming, and therefore that is the sum of the total non-conforming units, and then divided by the sum of the total number of units that you inspected. So this is like the weighted average, the average proportion of non-conforming units. And when you get this p-bar value, you need to plug in the different n value associated with each subgroup. So for example, in this March 29, we inspected 2,385 units, and therefore the p-bar is this 0.020, and then the n here in the control limit, when you're computing, you should plug in the 2,385. And now for the March 30, you inspected 1,451 units, and therefore the control limits for the March 30 should plug in the n30 here. So you should use the n value as 1,451 here to compute this upper control limit and lower control limit for March 30. And therefore, when you draw the control chart, you can see that we do not have a uniform line as the UCL or the LCL. We actually have 25 individual UCLs and LCLs. So you compute this upper control limit and lower control limit for each of your subgroup. The horizontal line is the index for the subgroup or the date of the inspection. So it identifies the different subgroups. And then on the vertical line, it reports the p-value associated with each subgroup. So that's the fraction of non-conforming. That is this p-value that you computed, which is drawn on the chart. And then you have to draw this UCL and LCL for each of your subgroup. So this is what a typical p-chart with variable subgroup size looks like. The step 5 in constructing the p-chart with variable subgroup size is still to establish the revised central line and control limits. So to compute for the revised central line, you have to discard the subgroups that are out of the control limit, as well as due to some assignable causes. And then you discard the number of non-conforming units of those discarded subgroups in the numerator, and then in your denominator, you minus the total number of units that you have inspected in those discarded subgroups. So here we discard 3 subgroups. And then we can establish this revised central line, and this P bar new becomes the best estimate of the P0 value that describes the actual fraction of non-conforming units. Now for the revised control limits, this is quite different from the P-chart with constant subgroup size, because you cannot actually calculate the control limits until the end of each day when the subgroup size, this Ni, is actually known. So as you can see, what we computed here, this N, is customized. This N is changing with your day of inspection or changing with the subgroup. And therefore, when we need to compute the revised control limits of the P-chart with variable subgroup size, you have to have some future data that are available. So like here, when we establish this P bar new, this updated P bar, and that will become the best estimate of the P0. And now we want to establish the control limits for the month of May. And now you have to have some more data, some future data. So like if I give you 3 more data in the May 3rd, May 4th, and May 5th, and then with different number of inspections, and then the number of non-conforming units in each of the subgroup, and you can compute these control limits for this future in this future time. If you do not have this information on hand, then what you can provide is just the revised central line. So now let's differentiate the several notations. So the P, this notation is the proportion or fraction of non-conforming in a single subgroup. This is computed by the NP divided by N. And the P bar is the average proportion of non-conforming of many subgroups. So as I said, this P bar acts as a weighted average. The P0 is the standard or reference value of the proportion of the non-conforming units based on the best estimate of P bar. And this can be specified. So if the P0 is known, then the process of data collection and the trial control limits is not necessary. So you do not have to use the P bar and then the updated P bar to better estimate the P0 if the P0 is already a given number. And as we can see, for the revised control limits in May, we actually used the P0 value that we got in April and March. So when we have an additional month of data, so by the end of May, we have one more month of data, then we can update this P0. And this will become a more accurate estimate of the P0. So like the P bar updated by the end of May will be a better estimate of P0. So the P0 should be evaluated periodically as you have more and more data. And sometimes if you know this phi is the population proportion of non-conforming units, then when this phi is known, you can just set the P0 as the phi. But most of the case, we do not know about the complete knowledge of the population.